Hi, I'm Ahanaf. I'm a rising junior at the Browning School, and the project I chose was, well, this isn't exactly one of the projects out of the handbook since this is my second session, and I decided for my second session I'd make a bit more of a custom robot, and so I got a bit of an upgrade for my older robot, which, as you may remember from my third milestone, was this bad boy right here. I got a bit of an upgrade to a more advanced robot. The name of the robot isn't really set in stone yet, but for the time being I just call it Spirit Junior. Spirit is one of the rovers of NASA, and I figured since I'm very bad at names, I'd just call it like Spirit Junior, like Perseverance Junior or something like that. So let's get into how the robot actually works. So, got this guy right here. So there's a number of components for describing how the robot actually works. I'm not going to get into all of that because in this video would be way too long, but in general, the main upgrades from the original ball tracking robot is this robotic arm right here that you can see. This thing has multiple servos attached to it that allow it to move up and down, as well as rotate side to side. We also have a number of other components like LED lights, bigger wheels, a kind of more tank-drivey robot compared to our older robot that only had 3 wheels, with 1 on the back and 2 in the front. We are also using some more hardware like the hat, which is kind of like a breadboard, but a lot more useful because we can connect direct power to it through our new lithium 3.7 volt batteries, which are pretty cool. The build itself is a lot more sturdy, I'd say, since most of it's made out of aluminum and the rest is made out of acrylic, compared to mostly plastic on our old robot, along with like everything being held together by tape. In comparison, this thing is mainly held together by tiny 1/5 inch of a finger screws. Another big challenge would definitely be the instructions. Frankly, they were pretty bad. This is a car by the company called Adeep. They have a pretty nice website, I will admit, but the instructions, I was not a fan. Anyways, with those unlikable remarks out of the way, I'm overall really happy with this robot. It looks awesome, like compared to my older robot. I'm just so glad how it looks. There's also this really cool camera mounting part in the front that like keeps the camera stabilized on the robot, which, as you may also remember from my older robot, the camera on the original robot was kept together by tape, as many things were. And yeah, so I'm pretty glad that worked out. First milestone. I'm going to show a quick demo of it moving since I did import that code from the older robot to this new robot. So let's get a quick demo. Alrighty, so the first thing we're going to display in this demonstration is going to be the default ball tracking part, or really the default color filtering and tracking part, which is a mechanism, if you've seen my other milestones, a mechanism my older robot had, which is sitting right there. And so let me run the program, and just like the old robot, this robot will idle until it sees a red object. And compared to the old robot, this one has a lot more control on its turning, because as you can see over here, the wheels do turn thanks to a servo on the front of the robot, and so it'll keep looking for a red object. If I give it a red object, which is going to be this piece of tape here, let's see. It sees it, and it starts coming towards it. And then once it does not see it anymore, it continues to idle. So I just have the robot propped up for a second here. That's not a question what it's doing right now. But over here, as you can see, the robot is currently looking at my bed. And based on some models I've trained and some pre-made models and some labeling I've done in the text files, it's able to classify this bed over here with 70 or so % accuracy, as you can see with that number over here. And it's saying that this image that's boxed around is a bed. If I were to put my hand here, you can see that it says person, and it's pretty sure it's a person. It has a 90% accuracy there. And then let's say, I don't know, let me get my keyboard real quick. So we have a keyboard here, and let's say we put it in front of the camera. It'll say keyboard. Oh no, oh, the robot is getting off the desk. Oh, we also have this cool OLED screen that I can make display in a second. All right, so the LED screen is now on. Displayed some text on it from my computer. And the final thing I want to show in this milestone is the movement of the servos. So what I did was I made this program, and what it does is you can use your keyboard to control these servos. And there's like 5 different servos on the robot. I know it might not look like there's 5, but there's 1 for the wheels, 1 for turning this thing, 1 for turning this thing, 1 for turning this thing, and 1 for turning the arm itself, like that. And so you will see once I run this program. All right, so what it does is the top key, so like QWERT, all like add degrees to the servos, which by default are set to 90 degrees. And then A, S, D, F, G all subtract degrees. I think it's by a factor of 5. So let's see. So Q, it goes from Q and A are servo 1, W and S are servo 2, and so on and so forth. And there's 5 servos, so these are the last ones. So Q will move it, will move the wheels in that direction. And then A will move in the other direction. And I'm not going to say every single letter, but that's basically, that's basically how this thing works. And whenever the servo gets out of bounds, it's reset to 90 degrees so that I don't get really hot servos, because that is a problem I used to have. I actually busted one of my servos doing that, which is not good. And then the coolest part is the claw. That's like, oh, that's not good. But yeah, that's about it. Thank you for watching, and hopefully my next milestone will be the final milestone of BlueStab for me. Goodbye.